Hello friends, how are you? Let's write one more ionic equation. Once again, we can recall the steps involved in the ionic equation. This first step, we need to balance the given chemical equation. The second step, we need to identify the ionic compound present in the given chemical equation and split the ionic compound into their ions. The third step is to identify the spectator ions and cancel the spectator ions. The final step, after cancelling the spectator ions, the left out the species need to be written as they are. Now let's work out the given equation. The given equation is for the reaction of aqueous potassium hydroxide solution with aqueous sulphuric acid solution to form aqueous solution of potassium sulphate and water. This reaction is a neutralization reaction. The first step we can follow that we need to check whether the given equation is balanced or not. Let's check now. The atoms I can list out. Potassium. The next one, hydroxide radical. This hydroxide is not present at the right hand side, so we need to break. Before that, we can go to the next reactant. In sulphuric acid, that sulphate radical is present on both the sides, so that is written as a single unit, sulphate. Then we can write this hydrogen and oxygen. Now we can list out at the left hand side as well as the right hand side. The left hand side, potassium how many times? 1 time. Right hand side, potassium is 2 times. Sulphate left hand side only 1 time. Sulphate right hand side only once. Hydrogen at the left hand side, 2 plus 1, 3, that is odd number. So we need to mention that odd number as well as the even number. Right hand side hydrogen is present only one place, that is 2 times. Oxygen at the left hand side only 1 time. Right hand side also only 1 time. This oxygen is separate. We are not taking into account of this sulphate. This oxygen we are not taking into account. That is already we have counted in sulphate radical. Now when we compare, potassium atom is 2 times the right hand side, but the left hand side only 1 time. Therefore, what we need to do, we need to multiply this 1 by 2. That number we need to write as a coefficient of potassium hydroxide. So when we multiply this 2 by potassium hydroxide, oxygen and hydrogen at the left hand side will change. Oxygen, previously it was mentioned 1, now it has become 2. Hydrogen, previously it was, I made hydrogen, I have changed hydrogen. Hydrogen, previously it was 1, but now after the multiplication of coefficient 2, it has become 2. Oxygen also will become 2 now. Now compare the right hand side. Now the left hand side, total number of oxygen atoms, this 2 plus 2, 4. 2 plus 2, 4. Sorry. This 2 is meant for what is that? that is hydrogen. So left hand side, how many oxygen atoms? That is 2 oxygen atoms. But the right hand side only 1. Therefore what we need to do, this 1 has to be multiplied by 2. That 2 we need to write as a coefficient of oxygen. This oxygen, that is the oxygen present at the water. So this water molecule needs to be multiplied by 2. Now when we check both the sides of the atoms, potassium both the sides 2 atoms, sulphate radical both the side 1, hydrogen both the side. Now hydrogen, after multiplying these 2 with the water molecule, hydrogen will change, that is 2 times 2, 4. So the right hand side, these 2 we need to change as 4. So hydrogen left hand side also 4, right hand side also 4. Oxygen both the side 2. So now the equation is balanced. So the balance equation is 2 moles of potassium hydroxide plus 1 mole of sulfuric acid gives 1 mole of potassium sulfate and 2 moles of water. So after balancing, the next step we need to go. So these works we can erase it now. So we have got the balance equation. The next step is to separate the ionic compound into ions. We need to identify the ionic compounds now. What are the ionic compounds? Potassium hydroxide is an ionic compound. Sulfuric acid is an ionic compound. Potassium sulfate also is an ionic compound. Now we can separate into ions. This potassium hydroxide we need to split first of all, that is 2 KOH will be split into 2K plus 2K plus 2K plus then 2OH minus 2OH minus. Everything we need to write the physical state symbol, that is aqueous, 2OH aqueous plus sulfuric acid we need to separate, that is H2SO4. How it will be? 2H plus ions, 2H plus ions plus 1 sulfate ion, SO4 ion, SO4 that is SO4 2 minus ion, 2 minus aqueous. Now the product side, that is K2SO4. K2SO4 will be split into 2K plus aqueous plus SO4 2 minus aqueous plus 2 moles of water. 2 moles of water, that is liquid state. Now we have separated the ionic compounds into their ions. The next step is to identify the spectator ions. What are spectator ions? The ions which are present on both the left hand side as well as the right hand side. So which ions are present on both the sides of the equation? With the 2K plus aqueous present? Yes. two K plus ions are present on the left hand side as well as the right hand side. Therefore, we can cancel this. We can cancel this K plus aqueous ions. 2K plus 2K plus are cancelled because both are present on the opposite side. Same ions but present on opposite side. The next one, OH minus is not present on the right hand side. H plus is not present on the right hand side. But SO4 2 minus ions are present on the right hand side. So SO4 2 minus also is a spectator ion. So we can cancel. So in this equation, we have cancelled the spectator ions. They are potassium plus aqueous and SO4 2 minus aqueous. So after cancelling out, the remaining species left out, we need to write as it is. So the remaining species, what are they? That is at the left hand side, 2OH minus, 2OH minus aqueous plus next one, what is left out? 2H plus aqueous, 2H plus aqueous gives the right hand side, what is left out? 2 moles of water only. 2 moles of water, that is liquid. After cancelling out, now we have written the ionic equation. This ionic equation, when you check that, all the atoms or the ions, all the species are in the multiples of 2. Therefore, this 2 we can cancel. We can simplify as a whole. It can be divided by 2. So as a result, the final equation will become, OH minus aqueous plus H plus aqueous gives H2O liquid. H2O liquid. So this is the ionic equation for the given reaction. That is OH minus aqueous plus H plus H plus aqueous. H plus aqueous gives, this is OH minus aqueous. OH minus aqueous plus H plus aqueous gives H2O. This given reaction is the neutralization reaction. This neutralization is between an alkali and acid. The alkali is aqueous potassium hydroxide. The acid is sulphuric acid. In general, if an acid reacts with an alkali to form salt and water, the ionic equation will be OH minus aqueous plus H plus aqueous gives H2O liquid. Thank you so much for watching.